Welcome to Learn at Work, a webinar series by the journal Work, a journal of prevention, assessment, and rehabilitation. I'm Karen Jacobs, the founding editor of Work, and I'll be the moderator of today's very exciting webinar. So I'm happy you could join us. I'm going to turn it over now to our esteemed presenter. Welcome.
Thank you. Hi, everyone. I hope you are all fine, safe, and healthy. And first of all, I would like to thank Dr. Karen Jacobs for the invitation to provide this webinar today. My name is Fabiola Reinert, and I'm a professor at the University of Southern Santa Catarina in Brazil. And today, I'm going to present this webinar on how to integrate ergonomics into product design through the user-centered design approach. This webinar is about a paper that we published in Work, me and Professor Dr. Leila Amaral Gontijo, during a research that we were developing at the Federal University of Santa Catarina. This is a part of a bigger research that we developed during my PhD, and it involves a lot from the analysis of product design methodologies and ergonomics to questions about teaching ergonomics in Brazilian universities. So this is like the final part of this research, and with the proposal of a systematic to integrate ergonomics into product design. Well, everything started from the assumption that ergonomics and human factors is little considered in the engineering design practice, and that the design methodologies do not properly present the use of ergonomics. These assumptions arise from the experience of me and Leila, both ergonomics specialists and industrial designers, that during working and teaching to product engineers, we saw that the relationship between these two areas was overlooked. And this relationship is really important because we make products for people to make their life better. So how come we can forget people or don't make them the center of the product design, right? And so based on this kind of questions that we try to first understand this context, this scenario. And one important thing that we found was that some authors claim that this difficulty is due to the wide variety of ergonomic tools and the lack of information on which to use and how to use during the design process. And as one of the approaches to ergonomics is user-centered design, it was defined as another assumption that a formalized and standardized approach such as user-centered design associated with a well-structured methodology in the field of engineering can help engineers to better understand and apply ergonomics in the product development process. Let me just change here. To understand better the user-centered design, it represents techniques, methods, and procedures for designing usable products and systems with the philosophy that places the user at the center of the process. UCD's goal is to design the product to serve the user as opposed to the objective-centric product design, where the focus is on the technical solution. Although initially applied in the development of computer systems, the term came in the human-computer interaction field, it has gradually infiltrated other design disciplines, such as product design. The user-centered approach has proved to be an indispensable item for the development of good products that are easy to use, that meet the needs of the users, and are adapted to them. The UCD was formalized through ISO 13407, which guides, and later updated by the second one, ISO 9241, the part 210, which guides the incorporation of user-centered activities to obtain quality of use throughout the life cycle of interactive systems. This standard describes user-centered design as a multidisciplinary activity that incorporates ergonomics knowledge and techniques with the aim of increasing efficiency and productivity and improving human working conditions, as well as being complementary to existing design methodologies. This is the point. It is an approach that can be used with other methodologies to proving a human-centered perspective that can be integrated into different designs and development process. So we have a lot of research and studies about the importance of producing products with good usability, and a lot of concern with aspects related to the product use, due to several factors such as legal aspects, accidents, consumer demands, inspection agencies, market losses, among others. And it is crucial to find ways to integrate ergonomics at product design development. But the problem is the low correlation between the application of ergonomics and the product design methodologies used by the students, mainly in Brazilian universities, which shows that design methodologies generally do not give proper support to the incorporation of ergonomics in the engineering products design. These results are part of another paper on the subject that we published on the Journal of Engineering and Design, so I'll present the link here. And the important thing is that all of this suggests that if ergonomics is well integrated into the product development methodology, presenting in which steps to use it, the probability of its use will be higher. And considering that the UCD is summarized as an ergonomic approach to product design, and it's well-known and a standard, we propose a systematic using the UCD approach of ISO, because it is a formalized and accessible material, bringing more reliability to the systematic. And as I said in the beginning, the idea was to integrate ergonomics into a known and validated methodology that use the same language and techniques used by engineers in order to increase the chance of the effective use of that. So what we did was integrate the UCD approach in the methodology most used by the engineers and students of the Federal University of Santa Catarina, where the research was being developed. And this methodology was the PD process from Bach. It's a Brazilian researcher and professor that wrote the first book of product design process in Portuguese in 1983. So he's kind of well known here. And this is the phases and the steps of the methodology of Bach. The important part in this case is the design process right in the middle. So we have informational design, conceptual design, preliminary design, and detailed design. The integration of ergonomics through the user-centered design approach was done in this methodology, so its use will be facilitated by the prior knowledge of the students in this process. And about the UCD, here we have the phases from the UCD. And the important phases for us is that four in the middle, that is understand and specify the context of use, specify the user requirements, produce design solutions, and evaluate designs against requirements. So what we did was to integrate these both methodologies, and this is an overview of the systematic. We call it SIEPP. It means Systematic for Integration of Ergonomics into Product Design in Portuguese. So it stays like this. And here we show the correlation of each phase of the UCD with the phases of the product design and the methods that can be used facilitating the visualization of the integration of ergonomics into product design. The suggestions of the methods and tools to support each phase is given by the relation between the UCD phases and the product design phases, according to the ISO, and about the ISO technical report 16982, which presents the methods that support the user-centered design. So now we go phase by phase. The first phase is informational design. And the activities related to the integration of ergonomics in this phase come from the UCD phases of understanding the context of use and specifying user requirements, as we can see in the first block. And then we have the activities of these UCD phases, the tools that we proposed, and the results that we expected. So the main objective is the results, that is, describe the users, their characteristics, objectives, and tasks with the product and environment of use, and define user requirements in relation to the intent use context and system objectives. So this is the overview of the informational design with all these phases and the activities of the UCD. And the integration of the UCD activities in these activities of the informational design was then considering the correlation between them and the proximity of these objectives. So the main activities of the informational design are shown in this figure and where the activities of the UCD must be integrated, in addition to the suggested methods for each one of these activities. So in the definition of product life cycle, it is proposed to integrate the UCD activities to collect and analyze information on the current context of use and specify the context that will be applied to the future product. These activities can support the definition of the life cycle, and in order to carry out these activities, interview and questionnaires with the users of the product can be used, applying closed or open questions formulated based on the areas of interests in which the information needs to be raised. One can use focus groups and systematic observation of the user in the environment of use in order to understand how they use the product and to raise needs and information on the context of use. And test analysis as well, which collects information on the accomplishment of the activity with the purpose to understand all the tasks that are done with the product, registering the movements, the sequence of tasks, the different ways to use the product, perceiving failures and problems in this interaction with the user and the product. And according to the ISO, the purpose of these activities and tools is to understand the user, its characteristics, objectives, and tasks with the product, and the environment of the product use. They may review needs, problems, and constraints that might otherwise go unnoticed, but need to be addressed by the future product. At the end of these activities, it is suggested to organize the obtained information to better use them in the context of use model. It is like this. So it will be easier to use this information after. So it could be seeing the user, who is the target audience for the product, the user characteristics of knowledge, experience, habits, user objectives and tasks with the product, and the use environment with characteristics of the physical, social, and cultural environment of the use of the product. So later, this information can be used in the next activity. So in the elicitation of user needs activity, the UCD activity to identify user needs should be integrated, which has as a support tool the context of use specification, so elaborated in the previous activity. And at this moment, the information collected in the previous activities is used to identify user needs with respect to the context. The next UCD activity is to derive user requirements that integrates the activity of the informational design, transformation of user needs into user requirements. And in this activity, standards and anthropometric data can be used to make the user needs tangible and consistent requirements. For this, well-known bibliography in the area can be used, or in the case of specific users, it's possible to carry out the anthropometric survey with the users. And after this activity, the next one is conversion of user requirements into design requirements, and then analysis of the relationship between between requirements, where the UCD activity resolving trade-offs between user requirements is integrated. To perform this activity, one can make use of KFD method, commonly used in engineering design. KFD is a product design management method that helps in the steps of the systematic, although it's not part of the scope of tools for the integration of ergonomics. With the help of this method, it is possible to correlate user requirements with product requirements, defining degree of importance and obtaining measurable characteristics of them. And with the degree of importance defined, it is possible to classify the requirements, solving conflict of choice between them. At the end of this informational design, the design specifications are defined, and then the next step is the conceptual design. So we go to the conceptual design phase, and here we have the phase from the UCD, the activities, the tools, and the results, and the activity related to the integration of ergonomics in this conceptual design phase comes from the producing design solutions phase on the UCD, which has as main objective to define the product idea, taking into account user requirements. Here is the overview of the conceptual design, and with the design specifications for the informational design, we come to concept generation. And in this concept generation activity, the integration of the UCD activity to design user tasks, user interactions, and interface is proposed. This activity supports the idea generation of more ergonomic products, deciding how users will perform the task using the product, and allows the division of the system tasks between those performed by humans and those performed by the technology. Taking into account the extensive use in engineering of the functional analysis method to divide the product into its main functions, which would be the tasks performed by the technology, and the morphological matrix method, which supports the solutions of these functions, we suggest, together with the functional analysis, to develop the sequence of tasks. So it will be divided tasks performed by the user with the product, and will also allow to use the morphological matrix to find solutions for these tasks. In addition to the systematic methods for design solutions, which are more commonly used in engineering, such as morphological matrix, one can use intuitive methods, such as brainstorm and co-creation workshops, in which the generation of ideas is done together with the users. After this activity, the conceptual design ends with the concept selection activity, which can be done with several methods, resulting in a product idea. Then we go to the preliminary design, and the activities related to the integration of ergonomics in this phase are still coming from the UCD phase of producing design solutions, as well as in the conceptual design phase. However, these other activities have as their main objective to define the product layout. So this is the overview of the preliminary design. And going from the product idea, we have the activity of modeling and dimensioning. And it is proposed the integration of the UCD activity, making design solutions more concrete, with the support of modeling and simulation softwares, in addition to the standards and anthropometric data again, to assist in the dimensioning of the product. In the simulation and optimization activity, the UCD activity to be integrated is to alter the design solutions based on user-centered evaluation, which supports the product optimization process. So modeling and simulation softwares can be used, and a user requirement checklist to identify a failure in meeting the requirements and optimize the design if necessary. In the last activity, product and components specifications, the UCD activity to communicate the design solution, which has the same purpose as the product design activity, is integrated. In this activity, the product drawings should be made to allow better communication of the design solution to those responsible for the execution. And at the end, the output of this phase is the product layout. And then we go to the last phase, the detail phase. The activity related to the integration of ergonomics in this detail phase comes from the UCD phase evaluation the design and has as main objective to collect feedback on the strengths and weaknesses of the product from the perspective of the user. So this is the overview of the last phase. And in the activity development of prototype tests, it's proposed to integrate the UCD activity to evaluate whether the user's needs regarding the product were met. This activity will support prototype testings by evaluation it from the user perspective. In order to carry out this activity, evaluation and tests involving users through interviews, questionnaires, focus groups, and task analysis can be used to identify possible changes that could occur to improve the product, as well as allow the collection of information on users' new needs, providing feedback on the strengths and weaknesses of the design solution. And a long-term monitoring can be carried out, which allows more detailed feedback. After this activity, the detailed design follows with other activities resulting in a production specification. So after that, we need to verify the applicability of the systematic, right? So we did an expert evaluation and an experiment in the engineering education. So for the expert evaluation of the systematic, that we did with 5 specialists, an evaluation form with 8 questions about the systematic was elaborated, related to the applicability, clarity, and contribution of the systematic. All 5 specialists were PhD professors in engineering programs at Brazilian universities who teach or have taught product design courses, and 2 of them also taught ergonomics courses. After the evaluation, an experiment to verify the application of the systematic was done in the 2nd semester of 2016 in the product design courses of the Industrial Engineering program of the Federal University of Santa Catarina, a class to which I had access. So the application was given by a non-probabilistic sampling for convenience. The results obtained in this evaluation are presented in this table. So it shows the questions and the numbers of respondents in each level. We have the strongly disagree, disagree, reasonably agree, and strongly agree. The agree and strongly agree levels responses was considered good, since they suggest that the systematic fully meets or in many ways the questioned criteria. And based on the data in this table, it can be seen that the general average of questions 1, 7, and 8 was good, which means that the systematic has potential to be effectively assimilated and applied, as in question 1. The sequence of UCD activities in the form proposed is consistent with the product design process and allows the progress of the process, as in question 7. And in addition to the fact that the systematic presents elements that allow the integration of ergonomics into product design, as in question 8. Questions 2 to 6 regarding the presentation and comprehension of the systematic and adequacy of the tools proposed in each phase were evaluated positively by the majority of the participants, since the answers focus on the agree and strongly agree levels too. But we have one incidence in the reasonably. So it is assumed that the reason for this one in questions 2 to 6 is due to the fact that the document submitted to the specialists on the systematic was not extensive to the point of clarifying the form of use of each one of the proposed tools, because it is a summarized document. But the systematic was considered satisfactory, so since the answers focus basically in agree and strongly agree levels, indicative of the acceptance of the systematic by the specialists, and of the fulfillment of the criteria established in the questionnaires. And with the systematic approved, we goes through application of the systematic in engineering education. And the application was done in the product design course. This course has 72 hours and is offered at 2 different times, which allowed one of the classes to be the study group and the other class was used as a control group. So the study group used the systematic proposed to carry out the project developed during the class, and the control group used the methodology proposed by Bach without integration of ergonomics, as was already done by the head professor of this course. The structure of the course is theoretical and practical, and at the beginning of the course, the themes and design problem are defined, and then the professor presents the stages and activities of the design process in the classes, so the students can develop the project throughout the semester. In the control group, the teaching plan and the schedule already defined by the professor for the classes and the project development during the semester were used based on the PD process of Bach. And in this group, I assist the professor in the class, but without presenting the systematic proposal, only observing and recording the development of the projects as already done by the head professor. At the end of the course, a questionnaire was applied on the understanding and use of ergonomics in the product design with these students to compare to the study group. In the study group, the teaching plan and the schedule for the classes and the project development was developed along with the professor of the course, considering the systematic proposed. Here, I accompanied the course and taught the classes on the ergonomics tools to be integrated in the product design phases. And the other classes remain the same as the control group. In this group, the questionnaires about the understanding and use of ergonomics in product design was applied on the first class, in the first day of the course, and in the last day, to allow the comparison of these results after the experiment too. So, as I said, at the end of the course, the questionnaires was applied. So in the control group on the last class, and in the study group on the first class and on the last class. All the questionnaires were applied without prior notice to the students to minimize the influence of external factors. The students were informed about the questionnaires only at the time of application and explained that their participation was voluntary. The questions concern the understanding of ergonomics, how to apply ergonomics in product design, the probability of the student to use ergonomics in product design, and the importance of the user in product design. The open questions were categorized and analyzed through content analysis, and those closed by descriptive statistics. Also, at the end of the course, a structured interview was conducted with the head professor to verify his perceptions about the experiment and about the students' use the ergonomics. Here I show the main results of the questionnaires, because to bring the results of the projects will take so much time. So, but it's valid to say it was possible to perceive the influence of using the systematic in the project developed. Students in the control group did not consider the aspects in their projects, while students in the study group made use of the proposed tools and detailed the use of the product by the user. And about the social demographic aspects, I will show the results already comparing both groups. So the control group, the mean age was 23.8 years, and most of them, 80%, were between 24 and 26 years old. And 100% of them was male, distributed between 4th and 5th year of the engineering program. In Brazil, the program lasts 5 years. And 60% did internships in manufacturing or logistics area. In the study group, the mean age was 23.2 years, and most of them were between 21 and 23 years old. The majority of the study population was male and have done internships and were distributed between 4th and 5th year of the engineering program as well. As the ergonomics course is a requirement for product design course, all the students, both in study group and control group, had previously done the ergonomics class. And here we have the data about the ergonomics understanding. So the first graphic is the answer of the study group before the application of the systematic. So in the first class, in the first day of the course. On its side, we have the answers of the study group after the application of the systematic at the end of the course. And the last graphic on the right side is the control group, okay? So remember that 100% of the students in both groups had taken the ergonomics class, as the ergonomics course is a requirement for the product design course. So considering that, we can see that most students understand ergonomics as adapting working to man, right? It makes sense, as it's the main focus on the ergonomics course here. Almost 75% in the study group and 80% in the control group. And the others said study the working conditions, which is too right to valid the answer. But when we asked about product ergonomics understanding, students of the control group and the study group before mostly understand product ergonomics, such as the study of product dimensions or safe product, safe and comfortable product. While the students of study group, after the application of systematic, mostly understand it as the study of interactions between the users and the product. We also have here adapt product to user and wellness and efficiency in product use. But what is important for us is the product dimensioning in study group and control group, that later we'll see about this again. So about the ergonomics application in product design, students of the study group before and in the control group generally do not know how to apply ergonomics in product design, as we can see in this graphic. So 93.1% in the study group before say that they don't know how to apply, and 60% of the control group. It's important that, and while 100% on the study group before said that they know how to apply, right? But it's important that we analyze here that also the ones that affirm they know how to apply in the control group and in the study group before declare to know how to apply ergonomics, but for them, this is only on product dimensioning. as you can see above the graphics. So the same happens with the ones that declared to know in the study group before. So 40% of the control group say they know how to apply and say that there is only about product dimensioning. These answers show that there is a gap on product ergonomics knowledge, understood as the study of product dimensions, as we see in the last graphic. So the application of ergonomics in product design will be only about the product dimensioning. This limited view of ergonomics and its contribution to product design makes some students believe that they know how to use ergonomics in the product design process, even with limited knowledge, as well as harming the probability of using it. In the study group after that 100% said they know how to apply ergonomics in product design, the answers to the questions of how to apply were quite complete, citing phases of the design process and tools to be used. In order to facilitate the treatment of the answers, we categorize in cited tools. So with 100% quoting questionnaires and interviews, 71% cited the use of task analysis, 100% cited observations, 96.8% cited the context of use specifications, 100 the anthropometric data, 80.6% cited the standards, 100% cited the task sequence, and 100% the user ergonomics requirements checklists. So big difference, right? And here we also have a very important data. So before the application, 62.1% of the students in the study group stated that the probability of using ergonomics in product design, it was low, and 31% that this was medium. Only 6.9% said it was high. In the control group, 60% said it was low and 40% that it was medium. But when we asked the study group after the application of the systematic, 96.8% declared that the probability to use ergonomics in product design was high. So we have a big difference in opinion here with the use of the systematic. Regarding the importance of the user in the product design, we ask if they consider that it is not important, little important, important, or very important. And what we see here is that even though in the groups that they affirm they are unlikely to use ergonomics, they see the importance of the user. Of course, that goes up in the study group after the application, but even in the other graphics, we can see that the students consider it important or very important, since the answers were concentrated in these 2 of 4 possibilities. And here, in the same sense as the previous questions, an important thing that we decided to ask was about the user-centered design, considering that the term could be more intuitive and easily understood than ergonomics. And what we see is that the term is better understood. In all situations, the greatest frequency on the meaning was in design focus on the user, and in considers the user and all stages. What it means for us is that the use of this term and this approach to integrate ergonomics can be a great advantage, because even in the control group, they have a clearer understanding of the term user-centered design. So the use of the systematic through the semester, presenting the ergonomics tools that can be used in each product design phases, helped in the understanding of ergonomics and how to use it in the design process, as well as change the mindset of students regarding the importance of using it, since the probability of using the knowledge has increased from low to high. And presenting this content of ergonomics properly and together with the design process allows students to be more likely to use it, to understand it better, and to know how to use it. And also, the results show that even before the use of the systematic in the study group and in the end of the semester in the control group, students see the importance of the user in product design and have a better understanding of this term, user-centered design, since the term refers in his name to the focus of the user of the product. So in this way, we believe that the use of the term can help in the dissemination of ergonomics used in product design, since the term is more intuitive and the students consider the use important. Regarding the head professor's impressions about the experiment, the professor comments that the experiment was well conducted by the researcher, and when asked about the attitude of students regarding the application of ergonomics into product design, based on his 30 years as professor of this PD product design course, he commented that the students emphasize the technological solutions, leaving aside other aspects. The professor stated that the ergonomics used in product design is not presented in the course, nor required of the students. However, the application of the systematic is in one of the classes, presenting the tools that can be integrated in the product design phases, allowed a greater attention of the students in this ergonomics aspect. So developing products focus on the technical solutions, but adapted to its user as well. And as conclusions, considering that engineering students do not use ergonomics in product design mainly because they do not know how to use it, presenting this information in a systematized way supports its use by increasing the ergonomics use probability. The evaluation and practical application of the systematic were fundamental to verify its applicability, in addition to its clarity and contribution, showing positive results, that the students on the study group develop a better knowledge about product ergonomics and its use, besides the data confirming that the probability of using ergonomics in the product design went from low to high after the experiment. Moreover, the head professor considered the application satisfactory and the experiment valid too. However, one limitation of this application is that it was not possible to perform it also with a class of mechanical engineering program in which students do not have ergonomics course in the curriculum, but they have the product design course. And we think it would allow the comparison of the results in the two programs to see if it's going to be any different. And finally, it is expected that this research has made evident the need for other studies in the area, allowing the analysis of how the systematic can support the integration of ergonomics in product design, and of course that the study presented may be used by engineers and engineering students, making the integration of ergonomics into the product design a systematic practice. Thank you for listening.
Thank you so much. This was so interesting. Well, we do have a question from Sue in the UK. Sue shared, I think the user involvement is excellent. Have you looked at the cost implications of this approach?
Oh, yeah. Not really. We didn't try to go it profound on that, but we think it will be really, really important and really good if in all the process we could have the users together in the development. So probably the product will be better with better ergonomics, and
Great. No, I think it's something to consider in the future. No,
Yeah, right.
yeah, for sure. Um, I'd love to ask one question before we conclude this very interesting webinar. What's next on the horizon for you? Um, why don't we say, it will be easy to get funding. What would you like to do next?
Actually, when we were doing all this research, at the beginning, the intent was to do this systematic proposal. But during the time that we stayed researching that, we saw that there is like just the first level, you know. We have a big problem about the ergonomics into product design in Brazil, and I think maybe in other countries too. But what we saw is that the methodologies that don't proper present this is like the first stage of that. So we try to attack this problem by doing a systematic that it is going to be easier and faster to try to make engineers and students engineering to use and consider ergonomics into product design. But what we saw, there's another levels of this problem, such as the curriculum of the courses of the engineering program, because we have like a fragmented curriculum, and I think maybe in other universities in other countries is like this as well. So the student take a course and then he goes to another course and he forgets all the learning, all the content that he saw in the previous course. And this learning is stay like fragmented. So probably we have to rethink all the curriculums, the structure of the courses. So make the students see all of this more integrated and more together. And probably we have to rethink also the pedagogical model. So the teaching methods to make the students see the whole content and the whole learning, and how he can use the other learnings from the other courses in the course he's taking right now, you know?
Yes, as a faculty member, I think what you're sharing is really important. So, any last thoughts before we conclude this webinar today?
Yeah, I think we have to try to do this integration as professors in the academia. So try to talk better with other colleagues, so we can make like an integration of this contents. And of course, as ergonomists and industrial designer, I think these two fields need to be integrated. So I hope me and others researchers try to do other research in these things, these areas, so we can do better products, right?
That's wonderful. That's really a wonderful concluding statement. I want to thank you so much for sharing your knowledge with us. And for our listeners, we appreciate you coming to our Learn at Work webinar. I hope you'll come to future ones. You can learn about them on our work website, which is workjournal.org. You can see it right on this last slide. So thank you again.
Thank you, Karen. Thank you, everyone.
Thank you.